So today we're just going to go over functional programming and object-oriented programming. So generally, in the programming world, there are two types of programming paradigms. It's functional programming and object-oriented programming. And we've seen a couple. We've seen two of them so far. So I'm just going to create a file, OOP, or test example.py code, example.py. Okay, so functional programming, you've been seeing with all these, kind of like validate phone number would be considered functional programming. You just declare a method or a function, you have some sort of inputs, and you have an expected output. So like def, phone number, or add, takes in num1 and num2, and it has an output, print num1 plus num2. Nothing changes. It's just some parameters go in, and you get an expected output every single time. Let's run this real quick. Add 3, 5, Python example. We got 8. Okay. So functional program, we just declare a method, has some inputs. We don't really do anything else. We don't like store a bunch of stuff. We can have variables, but a lot of that stuff is immutable. We're not storing anything that long. Then we have object-oriented programming, which you guys seen with Boggleboard, like class, like restaurant. So object-oriented programming is not by far, but yeah, it is the more popular type of programming. And what differentiates, what can you tell me how object-oriented programming differs from just functional programming? Jordan?
I mean, they both can be imported, I believe, but classes can be you can make instances of them to run for specific things.
Okay. Why do we want to declare an instance of an object?
Because it's more like the real world.
It's more. Can you elaborate on that?
Well, object-oriented programming goes through like creating instances of objects like a car, and how, say for instance, we were doing that Boggleboard, and in order to create 16 dice with 16 sides, we had to append 6 sides to each dice. And that's what you would normally do in the real world.
So yeah, when I think about functional programming, an example of a real world, say you go to a fast food restaurant, you go up to the cashier who's taking an order, you give them money, they give you something back. It's always an exchange of put in one thing comes out. Object-oriented programming, I think of the people behind the scenes that are taking your order, they keep track of your order, which is considered, it's also called state in the programming, where they have to keep track of state. So they have the state of your order, what you ordered. Say you ordered a hamburger, they have to know what toppings you wanted on that hamburger. If you had any sides like fries or a shake, and then the state of that hamburger throughout the ordering process and the making of your order. So object-oriented, you have these class, or you have these objects that you utilize the class keyword, and then you have these instances of these objects. So fast food, like order, we have that instance, def, this dunder, takes in a self, and we can have a fast food order that takes in, what do you want, self dot, food type,
Price.
For fries, we can do beverage type. What am I doing? type. I have to pass this up. And this is like, we need to keep track of this instance of like all these variables. We need to keep track of that data throughout the application. So that's object-oriented programming. What else would we need? We need like size of beverage.
Well, the biggest one for a database would be like the price.
All right, yeah, we can do the price. Size of beverage, we can do the price. We can actually even like create this just like order and make an order object, like order, anyway, but I'm getting ahead of myself. Oh, what's going on? So instead of having to type in all those variables, but anyway, so we can even do what's like this within this class object. We can have like the state of order or state of beverage. Like, has it been, did someone fill it up yet?
Not to jump ahead, in your class, with fast food, you can set a state of object plus tax.
Yeah, like you can, yeah.
That would be a steady that would go.
Yeah. So that's, and now if we needed to, if we wanted to create an actual like peer function or unpeer function, like add or fast food, food, order. I want to like test the state of, let's do beverage state, like whether it's full or not. Or whether it's been completed, that order, that part of the ordering process has been filled. So initially it's just going to be false. Like complete beverage order. Then here we can just self.beverage state equals true. So if we want to like convert this into like a functional programming function, we'd always have to pass in the type, food type, beverage type, size, price, and then also like change the beverage state. So we essentially, every time we'd have to pass this in.
Yeah, like we were doing with
So,
recursive.
yeah, let's go into an example real quick. So my order equals fast food order. And I'm going to order a hot dog, Coke, oh, Pepsi,
Just kidding. Just kidding.
medium, and then the price is, $10. Now I can access, let's print my order. Let's actually create a print, just like the food type. Food type. Pass in the self, then print self dot food type. My order dot print food type, invoke it. Now let's run this real quick. Uh-oh, what happened? Fast food order takes in no arguments. Did I miss something?
taken cell.
My order of fast.
Fast food order has taken itself with pots.
Here? Like that? Okay. What am I missing? I'm clearly missing something.
On the your two underscores. On
Thank
the-
you. Ah. Let's run it again. Oh. Hot dog, cool.
No.
So I only have to run one print food method. If I wanted to like access anything else in here, if I did it like a normal utilizing functional programming, I'd have to type in everything, food type, beverage type, every time I wanted to access everything. But here I've got an instance of it right here. Let's see what else. Let's do an account. So say we're creating an account. What are some, you have an account in a bank, what are some things you need to keep track of?
Account number, balance.
Okay. Balance.
Interest rate.
How about self dot current balance? We need like the amount. We need account number.
Maybe open and close.
Routing number.
Routing number, account number,
Balance history.
balance history. Just keep it.
Pending transactions.
What was that last one? Aaron?
Pending transactions.
Pending transactions. We have deposits. So let's just start out with, in order to create an account, you need an account number and an initial deposit. Deposit. So we have current balance equals initial balance. Self account number. Is there anything else we need?
Should that say balance or deposit? Is it supposed to match the argument?
No, it doesn't have to. This is just the current balance. We have the initial balance, and we can always update. So the reason why we use object-oriented programming is because you can mutate the state. You can change the state. So what are some methods that
Deposit.
you can deposit?
Withdraw.
So deposit. So let's print, or what would this return?
Return
Balance.
initial balance plus current balance plus
Plus. I'm going to set this to a variable. Balance equals. Cool. Wait,
You want to deposit back the update your
correct. Balance equals self dot current balance. What else we want to do? Withdraw. 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 self dot current balance equals self dot current balance minus withdrawal amount. We don't necessarily always have to return a value, but we don't always have to print, give like the person back their information. All right, so let's create an account first. Tom's account equals, how much money do I have? What? None? 1,000. But what are other some methods I can do when with my account?
Close it.
You can close it.
Add interest.
You can add interest. What if I just want to view the balance?
Print receipt.
Or you can just view the balance. You don't need. I never print receipts. I don't want that paper. Print self dot current balance. All right. Account number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's run this. Oh, what the hell happened? Oh,
You need to make your initial deposit.
You put current balance.
what am I looking at?
Current under line 10, self that current balance equals initial deposit.
Ah, thank you. Sweet. Cool. Now let's print my balance. Tom's account dot view balance. Invoke it. So right now, I created an instance of Tom account. I created a new account with $1,000 balance with an account number. And now I can access all these methods with Tom's account by just calling Tom's account dot view balance and invoking. So let's clear that. Let's run this again, 1,000. But see, there it goes. Let's return. Let's run this again. There we go. Did you see how it delayed? If I just didn't return, if I just did print. All right. You always kind of want to actually return something, whether it's just return or actually return statement. So what else? What else can we do? There's this other. What if I just wanted to?
You can view transactions based on date.
We could do that. I just want to view what the account, like what the Tom's account looks like. So I did print, I'm printing Tom's account, which is an object. I just want to see what that looks like. Main account object. So I've got the account, which is the name, which is an object at these weird numbers, which is the memory address of where this instance is located at. But maybe I want to, there's this string, str, dunder, str. If you don't know what dunder is, it's like the double underscore. And this returns, I forgot how does this work? Is it self, let's look it up. Let's look up other variables. this underscore string. So I just Googled like that dunder, like in Python. There's all this information about it, how to print it. I just want to like understand how it works. I'm gonna do a string. So, okay, cool. This gives me an example. Return point to string self.y. You got this dot format self equals self. I'm gonna actually copy this and use it as a reference. So I copied this. So I'm going to try to like emulate what this is. So account. Then I'm going to see what this does. Self dot account number. I'm going to do comma. Well, let's look back at that documentation. So it actually just returns points. So account number. And then it does that dot format self equals self. Interesting. Now, how do I call this method? Let's look it up. I'm not 100% sure. So it looks like it says string. I have to say call string within there, the object. So I'm going to go down to here. I'm going to call string. I'm going to call Tom's account. I'm going to delete that. So I did string Tom's account. So it's going to run this object. So actually, I'm going to go back to keep this printout of the object. It's going to try to, it's going to run, look at string. It's going to look at the object. It's essentially going to come in here and look at, oh, string, print this. That's what I'm hoping happens. Wow, good, did it. Let's do a space. I'm going to do that again. Cool. See what happens if I do that. Oh, that's weird. So I guess it looks like print. If I just want to print Tom's account, that's what that does.
Okay.
So yeah, you can, reading the documentation, some people say str or the print method. If you just run print, if you want to just print the object, it'll come into here, it'll look if it has a string dunder method, and then it'll actually return whatever you want.
Do you make a view account number method that does the same thing? Oh, but that would defeat the purpose.
Correct. So then you'd have to invoke. So the question is, can you just create a view account number? Def.view account number. Then return print self.account. Did I miss something?
There's a lot. There's a period.
What am I missing a period of? Ah, thank you. So with this, so I'm just printing Tom's account, but in order to essentially the same, I'd have to do view account number and invoke it. Run that. The terminal, Python example.py. So that's kind of what one of the benefits of just having this string dunder method. Okay, keep going. You want to do some more examples?
Yeah. This is great.
So I'm going to create another file. Touch, code, platoon, cohort. .py, a code. So I'm going to create a class, code, platoon, cohort. And then init self takes in some students. Students. What else can it take in? Let's just create, what does a cohort take in? A name. That's all it really does. Okay. Name. Then equals name. And also has students, which is an array. So let's say it also takes in students. So I'm creating a code platoon cohort that has the name of the cohort, which in this case would be Juliet, and takes in an array of students. That's right here. I want to print these students, view students, self. So I'm creating a view students method. I'm just going to return print self.students. Let's create Juliett Platoon. So I'm creating a Juliett Platoon instance of a code platoon cohort that takes in a name and an array. Actually doesn't say anything about an array, but let's just make an array out of names. Oh my God. I want to do it all now. So I'm creating a code platoon cohort, takes in the name, Juliet, and then just some names, people in the cohort. So I'm going to print, what else? I want to view the students. So I can do Juliett Platoon dot view students, invoke it, code, Python, code platoon cohort. Cool. Anybody have any questions? What's something that any questions?
So if you wanted to, let's say that array is a value in a key value pair and an object somewhere else, you know what I'm saying? Like, you're not going to sit there and create an instance that
it has all the names.
That has every single time, right? When you want to refer to an outside data storage.
So the question was, when you create a code platoon cohort, you're not always going to want to import all the names of just the name, right? You want to reference an outside data structure. Correct. So yes. So let's go into that. So with students, what are some, let's create another class. So we'll do, I'm going to move down here. I'm going to create a totally new class. Let's take this array. I'm going to get rid of the students. I'm going to create a class, students, or student, and then create an instance of a student. So what are some name, branch of service, some other, that works good. Self.name equals name, self.branch of service equals branch of service. So right now we modified Code Platoon cohort to just take in the name, and we're creating another class students or student that it corresponds to a student. But now what if I want to add a student to the cohort? To the Code Platoon, add student.
So for every new type of object that you create, you want to have a new class?
Yes.
Okay.
Yeah, any new type. So we have the Code Platoon cohort has multiple attributes assigned to it with like the name of the cohort. It could be the time, like the date range that occurs. It could have, there's many attributes you can add. And we're also creating a class student that a student can have many attributes: first name, last name, branch of service, gender, all kinds of stuff, age, stuff like that. But the Code Platoon cohort also has some built-in methods that we want to do. We can like drop students, we can add students, stuff like that. So a student, and then we could self.students is append, right? Student. That's how we would add a student. So if we call add student, is that how we would like add a student to the self.students?
Or you could do a +1 every time you create a new one.
So
It's just for numbers. Never mind. Yeah, you would append them.
I see.
So let's create student 1 equals student. What are some attributes to the student? Say, what branch of service were you in? Army? Nice. Cool. Whoop. I just want to print. How do I, if I just want to print student 1, how do I make it display the name? So this is name.
Or you can make another message string.
Or I can do
Use
the dunder method, string method, self, then return name. Now if I print, I'm going to print the Juliett Platoon. I'm also going to print Silas's name for student 1. Let's run this. Going down to the terminal, I'm running Python.
You forgot the format.
I forgot the what?
At the end of
The format.
Oh, thank you. Equals self. Cool. So because Juliett Platoon doesn't have that string dunder method in it, it just prints the object. Now, how do I add, let's, student 1. What else we got? Marcos. Nice. So we're going to print student 1, print student 2, print student 3. So go back down to the terminal. I'm going to print student 1, print student 2, print student 3. Oh. Now, how do I add a student to the Juliett Code Platoon? If I delete these, I've got 4 instances right here. I've got a code platoon cohort instance. I've got 3 student instances. How do I add 2 students in the code platoon cohort?
Wouldn't you call your Juliett Platoon and then just pass in your student 1 or student 2 or student 3?
Let's try that out. Juliett Platoon dot, does it add student? I'm going to pass in student 1. Now once I add student self, and I'm going to return print self dot students. So before I call this, I just want to call Juliett Platoon. Well, that's not going to work. Let's see if this works. I'm going to actually add it now. Add student 1. So I'm taking Juliett Platoon instance. I'm calling the add student method up here, line 13. I'm adding student 1, which is an instance of student with the name Silas, branch of Army. Let's see what it returns. So go ahead.
Does the net need to? No, never mind. I was just like, sorry.
I could do that. So it printed student's object. So it printed it printed. So I'm appending the student object to an empty array.
Yes.
So it returned an array with the student object. So if I did this 2 more times, called it, got the first one appended, student 1, student 2, student 3.
Okay. So now.
Anybody confused or want me to elaborate on anything?
So now, Juliett Platoon instance contains 3 new objects
Yes.
from the student class.
Correct. So it's like a class within the Juliett Platoon cohort. In the students array is stored class student objects.
That gives you the object and the memory location, but how do you get the actual student name in there?
A few students run that after.
Let's, I don't know if this will work, but if we do, what we got? I'm just gonna create another method. Def.view first student. I'm not sure if this will work. Return self.students, the first array. Now can I call .name? Let's see. Print that. Juliett Platoon .view. I don't need to pass in any parameter. Oh, shoot. Not actually running code. Clear. There you go. So right here is by doing view student name. I can even do first student name.
It's because it has the attribute name whenever you're invoking it.
Yes, so this is like the action. This right here is the instance of student one.
Mm-hmm.
The name
The dot name,
that exists in the student class.
correct. And the reason why we're able to see it is because we use the print function. Otherwise, yeah. What else are you unsure about?
This makes sense as we're doing it. We're doing it ourselves.
All right, so I'm going to stop recording. Or actually, let's go over libraries. So yeah. So we've already been using Python libraries and JavaScript libraries. We've been utilizing the unit test Python library, which is a built-in library that comes with Python. And there's other external libraries like the IPython one we were using when utilizing embed. And external libraries are just code libraries that are written from other engineers to try to make your life easier. So they give you access to these libraries to do certain tasks to make your life easier. So here's a list of all these different Python libraries. Scrappy, there's like a bunch of them. NumPy is one we're going to be using. And in order to install Python libraries, we use that pip install, pip install. And then JavaScript libraries that we've been using, like Jest and that shallow array one. Those are all external libraries that are created by engineers to make your life easier. There's a bunch of them. So the big ones we're going to be using is React, because we're using our front end as a front end JavaScript library. Yeah, so React was created by Facebook, just an FYI. And then there's all these other libraries that are awesome. D3 is really cool. But you can actually import your library and create these weird things. These weird animations with D3. Ones I use are React Select. It's a good one. I don't think give you examples. This is all like I said, documentation on how to this stuff used. This essentially is just like a custom select, drop-down select. We can do a bunch of stuff. Chart.js. Chart.js. You can create charts, samples. So you can like create charts. Animate. Never used animate. Ooh. Ooh. Yeah. These are like front-end libraries. 3JS. Ooh. So I think 3JS, what is 3JS? But yeah, these are all libraries that are created by other engineers. Like, they give you the ability to use them, all this code, for your guys' projects. So, yeah.
Question. So when people say vanilla JavaScript, is that just coding without using a library or framework?
Yeah, like vanilla JavaScript is what we've been doing like today or like the past 2 weeks. Like just everything is just JavaScript functions, everything like that. Yeah, you're not utilizing an external library to accomplish your goal or solve your problem. What other questions do you have about libraries?
We're going to get into React more later.
Is one better than the other?
So you can, is one library better than the other? Yeah, so yeah, it depends on what you're using for. If not a lot of people use it, you can, so like npm react select is one I've been using. So you can go to the actual npm page, because when you install external libraries on JavaScript, you use npm install whatever. So you can go to npm and look at the package for like other information, how to use it. And then you can look over here at downloads. If it has a lot of downloads, like weekly downloads, that usually means it's pretty robust. And you can also go to the GitHub. This is literally the GitHub of account. This is what you're downloading. This is all the code that is required to make React Select work. And if you can look over here, if this stuff hasn't been updated in like 4 or 5 years, and people aren't, and also this is really low, it's probably not that, it's probably out of date. But here you can see people have been updating 4 months ago, last month, 28 days ago.
So who's actually going through and updating these libraries? What was that?
Yeah, the creators.
That would be MIT, I think, was on this one. MIT.
No, I think it's just, yeah, it's just engineers that had a problem. What happens is a company has a problem, and engineers, like either a company does it or like even like a group of engineers, like I have this problem, and they solve this problem their own unique way. They're like, oh, I'm sure other people have solved like ran into these problems.
But who controls like what actually makes it into accepted?
The owner of the projects, of the libraries. So there's this thing called open source. So if you have time, you can contribute to open source by helping solve bugs that are in these libraries, and you can push it, like fix a bug and push it, and then the owners of the libraries will review it and approve or deny it.
Well, you can have multiple approvals necessary to merge updates, right? Because it's not just like one person every time. Multiple
Right. Oh, no,
people
yeah.
to approve.
Yeah. But yeah, you can encourage to use external libraries when you're working on personal projects, stuff like that.